Very good morning, children. See, we had been discussing yesterday about this electrostatic induction. So, what we have seen yesterday in electrostatic induction was when a metal rod, what we were doing, to a metal rod, when a charged particle or a charged glass rod or anyone that is being charged by rubbing is brought to a metal rod which is placed on an insulating stand. What was happening? There was a drift of charges on the metal rod onto two sides. As I discussed yesterday, end A becomes a negative charge or a positive charge, and end B becomes a positive charge and negative charge, depending on the charge of the particle or the substance that has been brought near to this conducting rod. Fine. So that is where we have discussed about electrostatic induction. Now, moving on to that particular topic where we are trying to understand the charging of two spheres by induction. How can we charge two spheres by the process of induction? Now here you can see that, now this case, see there are two metal balls, or you can say small spherical balls. These are conducting materials. And these two balls A and B may be of the same size. They are placed on an insulating stand. So now these two metals A and B are placed on an insulating stand. Now the question is, why we are placing it on an insulating stand? See, if they are not placed on an insulating stand, what will happen? The charges that is being acquired on them, it will be earth. Fine. We discussed about the case of earthing yesterday, where they will be pulled down to the ground. So in order to avoid that, these two metals, these two spherical balls A and B, they are kept closer to one another. As you can see in this case 1, these two are placed closer to one another and they are placed on an insulating stand. Now, to this two metal balls which are placed closer to one another, what is done? A positively charged glass rod is brought near the sphere, say A, near the sphere marked A, a positively charged glass rod is brought near to it. Now, when this positively charged glass rod is brought near to this first sphere, what will happen? As we have seen in electrostatic induction yesterday, what will happen? All the charges which is opposite to the charge that is being brought, here a positive charge is brought. So what will be happening? All the negative charges, see, A will be acquiring a negative charge due to electrostatic induction, and since both these spheres A and B are conducting, at the same time B will be acquiring a positive charge. So due to the presence of this glass rod, positively charged glass rod, what's happening? A acquires a negative charge. All the negative charges in A, it drifts to the side of, towards the side where the glass rod is being placed, and B is being oppositely charged. That is, the charge on B will be the charge, the same, equal to the charge of the substance that has been brought here to charge it out. Now, so now in the presence of a glass rod, both of them acquires, both the metal spheres, they acquire two different charges. One acquires a positive charge and the other one acquires a negative charge. Now, what we are doing in this third case, we are keeping the glass rod near to what we say sphere A only. It is kept near to sphere A, and the gap between these two, are being increased. What is happening over here? We have separated the gap. In the first two cases, you can see that they are closer to one another, but here the gap is being increased. So, and still the glass rod is being kept over here. The glass rod is not yet removed. The glass rod remains in the same place. So, what will happen? Due to electrostatic induction, the charges remains. So, A becomes negatively charged, B becomes positively charged, and they are being separated. Then, in case 4, the glass rod is keeping at the same distance which we have taken in case 3. At whatever distance they were kept in case 3, at the same distance they are kept, and this glass rod is removed from them. You can see the glass rod is not over there. Now when this glass rod is removed from there, what happens? This particular sphere, so sphere A was having a negative charge because we have brought a glass rod. If in the case if it was a ebonite rod, if it was an amber or something of that kind, sphere A would be getting a positive charge and sphere B would be getting a negative charge. But here because we have brought a positively charged glass rod, so this sphere A it acquires a negative charge and sphere B acquires a positive charge. A and B are acquiring. But now since the glass rod is removed, see fundamental law of electrostatics which we have discussed yesterday, that like charges they attract one another, like charges they repel one another and the unlike charges they attract one another. So these charges, that is a negative charge on sphere A, they were on the left side and on sphere B they were on the right side earlier. But now because this glass rod is being removed, what is happening? These charges they get accumulated near to one another. Right? The right side of sphere A and the left side of sphere B, they acquire this negative and positive charges. They shift to the other side. Fine. Now here, again if the distance between both the spheres is further increased, if you are trying to increase the distance between both the spheres again, so this what happen, the charge gets uniformly distributed. Instead of being on the sides, the charge gets uniformly distributed over the sphere. So we get case A, or in the last case we can find that we get A as a positively charged, negatively charged sphere and B as a positively charged sphere. So this is how we can charge two spheres by the process of induction. I hope this is clear to you.